All right, welcome to The Explainer. Today, we are cracking open the black box on what is, without a doubt, one of the most transformative technologies out there, large language models. We're going to jump right in, how they actually work, the really tough challenges they bring up, and, what this all means for all of us.
I mean, you've probably used ChatGPT, right? Or maybe you've seen the wild stuff that Google's Gemini can do. It feels like magic. It can whip up a poem, fix some buggy code, plan your entire trip, and then explain a complex science topic like it's nothing. But here's the thing. It's not magic. Not at all. It's the result of decades of hard work, just insane amounts of data, and a few brilliant ideas that changed everything. So what's really happening behind that blinking cursor on the screen? Let's dig in.
All right, so here's the plan. First, we'll look at the AI we're already using every day. Then, we'll go back in time to see how we got here. We'll break down how these things actually learn, tackle the huge issue of bias, see what can be done about it, and then wrap up by looking at what's next.
Okay, first things first. Let's talk about where this tech is already making waves. The chatbots get all the attention, right? They're flashy. But the technology behind them, natural language processing, or NLP, is way bigger than that. It's quietly reshaping entire industries as we speak.
So check this out. What's so cool here is just how much is going on. Yeah, chatbots are a big piece of the pie, about a quarter of it. But look at everything else. Sentiment analysis, that's 20%. That's the secret sauce companies use to figure out what you really think about their new phone by scanning millions of tweets. Machine translation? That's changed how we talk to each other across the globe. But for me, the really mind-blowing part is that big 30% chunk labeled Other. This is where the magic is happening under the hood. In healthcare, summarizing mountains of research to find new drugs, or in finance, spotting market trends before they happen. It's a revolution, but it's a quiet one.
But look, to really get how powerful these models are today, we've got to go back. This didn't happen overnight. Not even close. It's a story of decades of work, building one idea on top of another, going from really basic math to these crazy complex systems that can actually start to make sense of, the beautiful mess that is human language.
So if you go back to the 90s, it was all about statistics, basically just counting words. Models learned that thank you shows up together way more often than thank tree. Simple, but it was a start. Then the 2000s brought neural networks, which could understand relationships like king is to queen what man is to woman. Pretty cool. But the real earthquake hit in 2017. A paper with the best title ever, Attention is All You Need, dropped, and it introduced something called the transformer. This was the game changer. It's the engine in everything from BERT, which got amazing at understanding context, to, of course, GPT, which just completely shattered what we thought AI could do with words.
And this chart right here just shows it perfectly. Look at that curve. For like 50 years, progress was fine, slow and steady, little baby steps. You can see it just kind of bumping along the bottom. But then, the last 10 years or so, right after Transformers came on the scene, the curve just goes vertical. It's that classic hockey stick growth. Every single breakthrough suddenly became a rocket booster for the next one. The pace is just insane.
Okay, so this is the big question, right? How in the world does a bunch of code learn to write poetry? How does it explain quantum physics? Well, the most important thing to get your head around is this. It's not understanding things like you and I do, at all. It's a pattern-matching machine on a scale that it's impossible for our brains to even imagine.
So it all kicks off with something called tokenization. See, computers are dumb in one way. They only get numbers. Words, sentences, emotions, nope, just numbers. So the very first thing we have to do is chop up all of human language into little pieces called tokens. Think of it like Lego bricks. We're turning every word, or even parts of words, into a specific numbered brick. We're basically translating the entire internet into a language of numbers that the computer can finally work with.
Okay, so we have all our text turned into numbers. Now what? How does the learning part actually happen? Well, there's this quote from a research paper that uses a fantastic analogy, and it's perfect. It's like training a martial arts master.
And that's pretty much exactly how we train these models. It's a two-step process. Step 1 is pre-training. This is building the foundation. The model basically reads, a huge chunk of the internet. Books, Wikipedia, code, everything. And its only job, over and over again, trillions of times, is to guess the next word in a sentence. That's it. But by getting really, really good at that one simple thing, it accidentally learns grammar, facts, and even a bit of reasoning. Then comes step 2, fine-tuning.
Now we take that super knowledgeable but general model and we train it on a much smaller, specific set of examples to teach it a particular skill, like how to be a helpful chatbot.
Now, the real secret sauce here, the thing that made all of this possible, is a clever idea called the self-attention mechanism. It's the heart of that transformer architecture. The best way to think about it is like a magic highlighter. When the model reads a sentence, this mechanism lets it highlight which other words are the most important for understanding each individual word. So in a sentence like, "The robot picked up the ball because it was heavy," attention helps it figure out that it refers to the ball, not the robot. It's how the model keeps track of context, and it's absolutely brilliant.
Okay, but there's a huge catch to learning from, well, us. The model is trained on a digital mirror of our world, and that mirror is cracked. It reflects all our amazing creativity and knowledge, for sure, but it also reflects all of our biases, our prejudices, our stereotypes. And since the AI is just a pattern-matching machine, it learns those ugly patterns too. This is the ghost in the machine.
And this bias problem really shows up in two main flavors. The first one is simple: data bias. It's the old saying, garbage in, garbage out. If the data you feed the model is biased, the model will be biased. Simple as that. But then there's a trickier one: algorithmic bias. This is when the design of the model itself accidentally takes a small bias in the data and turns the volume way up, making it much worse. So here's a perfect example of data bias. You type in something like, "the doctor said," and the model is way more likely to follow it up with he than she. Now, the model isn't sexist. It just read billions of pages of text where, historically, doctors were referred to as men. It's just spitting back the most likely pattern it saw. It's a reflection of our past. And this isn't just about gender, it's about culture too. So much of the internet is written in English and comes from a Western perspective. So if you ask the AI what are some important holidays, it's probably going to talk about Christmas and Thanksgiving. It might totally ignore things like Diwali or Lunar New Year, not because it's trying to be exclusionary, but because that's the data it was fed. It accidentally makes one worldview seem like the only worldview.
And you see this pattern everywhere. Racial bias, where it learns harmful associations from biased news. Socioeconomic bias, disability bias, political bias. It just reflects the loudest voices in its training data. And look, this isn't just some academic thought experiment. When we start using these tools to make decisions about loans or hiring or medical care, these biases can have serious real-world consequences.
So, this brings us to the million-dollar question. What do we do about it? If the AI is just a mirror, can we build a better, less distorted one? Well, people are trying. It's a huge field of research, and the solution seems to be a mix of smart tech and just better, more thoughtful processes. On the tech side, there are some really clever tricks. First, you can build tools to just measure the bias, to put a number on it. Then there's stuff like data reweighting, which is basically telling the model, hey, pay more attention to these examples from groups that are usually ignored. My favorite, though, is adversarial debiasing. It's like you train a second AI whose only job is to try and expose the bias in the first AI. It's basically an AI ethics cop, and it forces the main model to get better. But, code alone isn't going to solve this. It's not a silver bullet. You also need a strong ethical game plan. That means building fairness in from day one, not tacking it on at the end. It means bringing diverse people to the table, especially from marginalized communities, to help build and test these things. It means you have to keep watching these models after they're out in the wild. And crucially, it means being transparent about what you've done, so everyone can see how you're trying to make it fair.
All right, let's look ahead, because bias, as big a deal as it is, isn't the only challenge on the horizon. As these tools get more powerful and woven into everything we do, a few other really big hurdles pop up.
Yeah, there are some big ones. First, privacy. These models have read so much stuff they can sometimes act like a parrot and repeat sensitive info they saw online, like someone's phone number. That's not good. Then there's safety and the whole hallucination thing. You've seen this, right? When the AI just makes stuff up with complete confidence, that's because it's designed to sound plausible, not to be truthful. And finally, intellectual property. If an AI writes a song that sounds just like a Taylor Swift song, who gets sued? Who owns it? We honestly don't have good answers yet.
And look, the stakes for figuring this stuff out are getting higher every single day. We're not just using these things to write funny poems anymore. They're starting to show up in medicine, in finance, in our legal system, and in those fields, you can't have pretty good. You need fairness, you need safety, you need reliability. The
The potential for good is enormous, but we have to be incredibly careful and responsible to make sure that's the path we take.
So that leaves us with a really deep question to chew on. We've said that AI is a mirror of our society, right? It reflects the good, the bad, and the ugly. So, to fix the AI, to get rid of its flaws, do we have to fix our own first? It's a wild thought, where fixing the code means fixing ourselves. That line between technology and humanity is getting blurrier all the time. We're going to be digging into more of these questions in future explainers. Thanks for sticking with me.